Okay, sorry about that, I'm back. Just ran out of time in the last video. So, yeah, so enter your numbers in your list. You can name it whatever you want as long as you're able to recognize it. So, enter in your list 1.01, 0.99, 1, 1.03, 1.01, 1, 0.98, 1.01, 1, and 1.02. And then once you're done with that, go to second, click second, and then hit Y equals. You should see where it says, if it says plot off, turn it to plot on. And it'll show you what type of display you want. Go over to the third one on the top where it says histogram. And then under X list, type in the name of the list that you want to make a histogram for. Leave the frequency as 1, and then hit graph. And then once you hit graph, you can hit the trace button, and it will give you the intervals. And it should look approximately normally distributed. Your calculator should. And so since the histogram is approximately normally distributed, we can continue. One important thing I forgot, if you want to change the intervals, you just hit window, and where it says X min, hit a reasonable interval, and X max, hit the highest X value you would want, and then X scale, put it on a reasonable interval. So for this, I choose my X min as 0.98 since that was the lowest value. And my X max is 1.03 since that was the highest, and X scale as 0.01 since the numbers are all kind of close together. So yeah, the histogram should look relatively normal, so that is satisfied. Our second condition is that the observations are independent. And for that, n has to be less than or equal to 0.1 of all n. So in this case, is 10 less than or equal to 0.1 of all n. And multiply each side by 10 is 100 less than or equal to all n number of paint buckets in filled in ABC Paint Factory. And we can assume that they are, especially if it's a larger factory. And even if it's not, we'll just have to assume that it is. So the third, you just kind of have to have faith on that one, and that is that the sample was randomly selected from a population of interest, and in this case we have no reason to believe that it's not. So step 7 is you have to compute the test statistic, and for that you should clear your screen and go to stat, scroll over to where it says test, and then scroll down to number 2 where it says t-test. Click on that, and where it says input, it's either data or stats, but since we made a list, you should see data highlighted. Click on that. Go down. The mu of O just means the hypothesized amount. So in this case, if we go back to our problem, that was 1 gallon. So just hit 1 there. And then you want to type in the name of your list. I named mine, again, BUCK. Leave your frequency as 1, and then where it says new, remember if we go back to our problem, it wanted a different amount. So click on where it says does not equal to. And then you want to hit calculate. and you should get an X bar value that equals 1.01 or approximately that. I think the calculator will say 1.005, but if you round off, it's 1.01. The N, which is the number of cans in this case that were sampled, that's 10. And then your T value is 1.10. The T value is, you don't really need to use that for this problem, although it's good to have, and same for your, well, if you wanted to calculate it manually, you might need it, but since the calculator just gives it to you, you don't really need to worry about that. Same with the standard deviation, which in this case is 0.014. Now for the important part is step 8, which just defines the p-value, and that should be given to you in your calculator. So as you can see here, the p-value is 0.2987, so we can round that up to 0.3. And then the last step, just like in the null hypothesis for proportion, is to reject or fail to reject the null hypothesis and to interpret it. So just to recap, when the p-value is less than or equal to the significance level, then you reject significance, and you reject the null hypothesis. However, when the p-value is greater than a or significance level, then you fail to reject the null hypothesis. So in this case, our p-value of 0.3 is greater than our significance level of 0.1 that we found back in step 4. So in this case, we want to do this option, where you fail to reject the null hypothesis. So that means we can interpret the data now. So we found convincing evidence at the 10% significant level that the buckets do indeed contain 1 gallon. And this means, obviously, that the machines do not need to be recalibrated, because if we go back to the problem, it says if it's a different amount, then the filling machine should be recalibrated. But we found that it wasn't, so the machine does not need to be calibrated. So, meaning the machines do not need to be recalibrated. So, that's it. I hope that you found these videos helpful, and best of luck with solving these problems. Thanks for watching.